Assalamu alaikum. Welcome to mathematics class for standard 7th, chapter 14, Symmetry, part 3. In this chapter, you are going to learn about regular polygons. You will also learn line of symmetry of alphabets. This is an equilateral triangle, isosceles triangle, and a kite figure given to you. In equilateral triangle, all three sides are equal. All three sides are equal and all three angles are equal. For any regular polygon, regular stands when? Regular word means all sides are equal and all angles are equal. Then such polygons are said to be regular polygons. So for three-sided figure, they are called as triangles. For four equal side and equal angle, they are called as square. For five, it is called pentagons, and so on. We'll study later in this video. Equilateral triangle means all sides are equal, all three angles are equal. So when you are going to draw a line of symmetry from any edge, you will be able to see that the left half is always equal to the right half, and they are the mirror images. So for equilateral triangle, you have three lines of symmetry. Isosceles triangle have only two lines equal. So the base side is not equal to the other two sides are equal. So when you are going to draw the line of symmetry like this, your left half will be equal to the right half, and exactly mirror halves they are. So isosceles triangle has only one line of symmetry. A kite has this side equal to this side and the long side equal to this long side. So when you are going to draw a line of symmetry like this, your left half will be the mirror image of the right half. So a kite has a how many lines of symmetry? Only one line of symmetry. For rectangle, as we have two sides equal and two angles equal, right? So a rectangle has a vertical line of symmetry which will divide the rectangle into two equal mirror halves, as well as the horizontal line of symmetry will make the upper half and the lower half equal, and as well as the mirror images of each other. This is a regular polygon called as square because four sides are equal and four angles are equal. So you can say that for any regular polygon, the numbers of sides and angles, there are four equal sides, four equal angles, so the line of symmetry will also be 4. So in short, you can remember that for a regular polygon, the numbers of side is actually equal, will give us the equal numbers of axis of symmetry. So your for square you have 1, 2, 3 and 4 lines of symmetry, and for rhombus all four sides are equal definitely, but four angles are not equal. So this is a condition which is not valid for the lines of symmetry, because this will change the overlapping. When we cut the half, it will definitely not going to give us the mirror reflections. More than two axes of symmetry cannot exist in rhombus. That means let us see, this is a line of symmetry and this is also a line of symmetry, but suppose if you want to cut like this, so this won't give you. Now let's see how it is not giving us. So let us draw this one. So because of cross, the angles are different, right? One is acute, these sides are opposite are acute, and these are the obtuse one. So what will happen? They will not exactly overlap. Some of the corners will be out of the edges, and that's why a rhombus does not have more than two lines of symmetry. A rhombus have only one line of symmetry. This is all irregular polygons. Means your isosceles trapezoid is there. That means isosceles means only two sides equal. So this side we can say this side is equal to this side, and this is the line of symmetry which will divide it into two equal halves. Now look at this trapezoid. So first of all, isosceles trapezoid have one line of symmetry. Now look at this trapezoid. It is not having any side equal to other. All four sides have different length. So what will happen? You know, this will give you no line of symmetry. Wherever you will try to cut this figure from wherever you want, it won't give you two equal mirror halves. Look at this parallelogram. Definitely it is having two equal parallel opposite sides. See, but what happened? Due to unequal angles, they are not able to overlap, as well as the figure is a little bit crossed. As you can see, the parallelity is not exactly at the same point. So this point having the perpendicular here, we can say, though if you are going to cut it, the overlapping is done only when there are straight edges perpendicular to each other, right? So here it won't be possible. For parallelogram, that means there will be no line of symmetry. Now look at these figures. These all are regular polygons. This is regular pentagon. Pentagon means penta stands for 5. So this is having pentagon, 5-sided figure, 5 angles equal, 5 sides equal. So this figure, as I told you earlier, regular polygons to whatever numbers of side or angle they are having, that many lines of symmetry will exist. So 5 lines of symmetry for pentagon. Now this is hexagon. Hexagon stands for 6-sided figure. Regular means all sides equal, all angles equal. So how many lines of symmetry will be there for hexagon? 6 lines of symmetry will be there. Look at this heptagon. Heptagon means 7-sided figure, 7 angles figure equal, 7 sides equal. So how many lines of symmetry this will have? It will have 7 lines of symmetry. Understood? So in short, we have now able to tabulate them and write them. Lines of symmetry, how many for the figure? So first is square, 4 lines of symmetry, and in the third column they have shown you drawing that dotted lines to show you where the lines of symmetry exist. So parallelogram has no sign of line of symmetry, that's why no dotted lines in that. Rhombus has 2, so both the dotted lines show you in this rhombus. Equilateral triangle, hexagon, circle. Circle is having many lines of symmetry. You cannot count it. From every point of the circle, you will be able to draw one axis of symmetry. Okay, so even the point needle side, needle pointed, you know, the pin side, pin sized dot also, if it is there on the ring of the circle, from that point also you will be able to draw the axis of symmetry passing through the center of the circle. Okay, so that will cut the mirror, the circle into 2 equal mirror halves. Now look at this figure. Here some shaded boxes are there and some are not there. What you have to do? You have to choose one line of symmetry. It could be any. Okay, suppose you want to draw like this a line of symmetry. Suppose you want to take this line of symmetry. Suppose you want to take this line of symmetry. You take any line of symmetry, but make sure that whichever you take one. Suppose you are taking this line of symmetry, the vertical one. Let me draw it properly. Suppose I am taking a vertical line of symmetry. Now whatever shaded figures are missing here, we are going to draw it. See, this black half is this side and this side, so it is done. Now look at this sided figure. Here it is there, but here it is missing. So what we are going to do, with pencil we will shade it so that my half figure must look same. I'm going to shade it. Now look at this square. Here it is not there. So what I will do, I will shade it. Right. Look at this figure. This shaded box is there. So here shaded box we have to draw. The shading must be done in this way that it should be equal. Look at here. This box. Here it is missing. So we have to shade the box so that the line of axis which we have drawn should give the mirror reflection of these boxes. You understood? You may take any line of symmetry. Suppose this I have taken vertically. If you want, you may take horizontal also. And then see the boxes where the missing shades are there for the reflection. You shade them with pencil. Okay. Not only this kind of horizontal or vertical. If you want to take a cross one, you may take that also. So it is up to you. You may take it and you may draw it. Okay. And move ahead. Okay. Go on with the next one. Now this is a reflection figure where one half is drawn and given to you ready. The other you have to draw. So how you are going to look at that? See, I can tell you. First of all, look at this. We have to count the boxes. Here it is drawn 1, 2, 3, 4, 5 boxes are there. So what we will do, we are going to count. One thing to keep in mind very clearly, that from the line of symmetry or axis of symmetry, your mirror reflections are always left to right. That means if one side is moving towards left, your reflection should go towards right. Only this matters. If your reflection, if your image or figure goes down, then in reflection it does not go up. For up it is up, for down it is down. Only for left it is right, and for right it is left. Only this opposite we have to take. For up down we don't have to take. That means these four boxes, this 5 boxes we counted, it is going towards the left side. So here the image will go, our reflection will go towards right side. Now look at this boxes, they are going, the line is moving downwards, 4 boxes, see, downward. So in the reflection it will also go downward only, it will not go up. I repeat that only for left the reflection comes right, and for right the reflection comes left, but for up it is up, for down it is down. Okay, now look at this 4, 1, 2, 3 figure boxes, the line is going towards right like this. So the reflection will go towards left like this. Now for down it is down. Again for this the figure is going to come like this. You understood how to draw the reflection? Now it is easy for you to understand, right? And easy for you to do it by yourself. Let's move ahead. See this figure. Now it is easy. Only for left it is right and right it is left. For down it is down only, right? So what we are going to do? We are going to draw it. See, a number of boxes you count, that will be more easy for giving you to give you the accurate reflection. 1, 2, 3 boxes, right? 1, 2, 3 boxes. Left, so here it will go right. Okay, now down. 1, 2, 3, 4 boxes down. 1, 2, 3, 4 boxes down. Now 2 boxes left, so 2 boxes right. You understood? Then down, so we are going to take this much down. Okay, then it joins. See, we have completed the reflection figure of the given image, right? I hope you can do it for the rest of all if it is given you in your exercise, right? We'll move ahead. We're going to see some of the this video to understand that how the letters reflection works, right? Look at this. The symmetry of capital letters. Here I have taken A and line of symmetry is horizontally drawn green color, as well as I have taken a blue one to identify that whether both are right or not. See, the overlapping is only correct for the green, that is vertical line of symmetry, but for horizontal line of symmetry the overlapping is not correct, right? So only green line is the correct line of symmetry, so A has only one line of symmetry. Now look at, take as H. I've taken this green dotted line as an axis of symmetry vertically, and blue I have taken horizontally, right? Now I am overlapping for vertical and now overlapping for horizontal. Both the way it is overlapping very correctly, that means. So what we can say that yes, for H this vertical green and horizontal blue, both the line of axis are correct. So letter H has 2 axes of symmetry. Now, let us watch the lines of symmetry of the alphabets. All alphabets you have taken here A. This line gives you half figure. So A has one line of symmetry. For B, only horizontally it overlaps. So one line of symmetry. C, only horizontally gives the mirror halves. So one line of symmetry. D, only horizontally it gives the mirror half. So it is having one line of symmetry. E, only horizontally it is overlapping each other. So one line of symmetry. For F, we tried all the way, cross, vertical, horizontal, not possible, no line of symmetry. For G also we tried all the 4 ways, but no line of symmetry. For H, we did earlier also, it has 2 lines of symmetry, right? For I, see, horizontal also equal and vertically also equal. So I is also having 2 line of symmetry. J, not possible, all the 4 way you try it, not possible, right? So J is having no line of symmetry. K, again not possible. See, not possible, right? All the 4 ways we tried, no line of symmetry. For L, again we tried all 4 ways, no line of symmetry. M, vertically yes, it is possible, right? One line of symmetry. N, tried all the 4 ways, not possible, right? So no line of symmetry. For O, it is radially available, means from all sides, whichever point you want, so infinite line of symmetry. For P also we tried all 4 ways, right? That is not possible, no line of symmetry. For Q also We tried all 4 ways. No line of symmetry. For R also, trying all 4 ways. Not possible. No line of symmetry. S also gives you the opposite curves. Reflection must come. Mirror reflection, if it is there, then only. See, S is no line of vertically possible for T. Yes, one line of symmetry. U also possible one side, one line of symmetry. For V, yes, one line of symmetry. For W, yes, one line of symmetry. For X, it is possible. See, this horizontal also possible, vertical also possible. Then this also possible, diagonal wise. Cross this one. Okay, always possible. How many lines of symmetry? 4. Look at Y. Only one possible, one line of symmetry. For Z, we trying all 4 ways, not possible. So Z is having no line of symmetry. So I hope students you understood that the lines of symmetry divides any figure or shape into two mirror halves. There will be no line of symmetry for any irregular shapes, polygons or letters. I hope student you understood whatever was there in the video. Okay, I hope the concept which was there in the video is now clear to you. Thank you. Have a nice day.